Hi, I'm Joe Fields. I'm the immediate past chair of the Northeastern section of the MAA, and I'm also a professor at Southern Connecticut State University. It's the middle of March. In fact, it's Pi Day. Happy Pi Day, March 14th. And we are now in the process of transitioning our college courses to online delivery. I think many schools in the Northeast, if not almost all at this point, have made the decision to try to quell the spread of the coronavirus, that we would cancel physical courses, that is on-ground courses, but move them in, if we need to continue the instruction. So my point right now is to kind of share with you my approaches to doing exactly that. You can see I've got a whiteboard installed in my house, which maybe is a little weird, but maybe not for a math geek. Not everyone would have this, but I think you can make pretty reasonable alternatives. For instance, a roll of brown paper that you can write on with a Sharpie and then discard as you go. I kind of like the idea of having my face, my physical presence in the frame, so that the students feel like they're really seeing the same thing they do in class. But you could do like a Khan Academy style thing of just aiming a camera at a sheet of paper while you write. Even a little more high tech, you could do capturing of writing via like a touchpad or an iPad. Okay, so my goal is basically to show you three modalities for potentially delivering your content. And we have to face a certain fact of life at this point, that active learning is going to be more difficult to do in this medium. So we're essentially going to have to fall back on lecture plus whatever else. Now, we can do certain things. For instance, you could have students work in groups where the groups would join a Zoom meeting together, or there's other technology that allows them to do video conferencing. Google Hangouts, or my school has WebEx, and also they can do things via the Microsoft Teams. Any of those alternatives, they're less good than being there in person working with them, but you should be able to join the meeting yourself and talk to the groups one at a time. It's a little less easy than moving about the room, because there may be a synchronicity problem where the students all actually working at the same time. Perhaps that's something we can demand of them. You still need to do certain activities during the scheduled class time. Usually in online delivery, that's not the case. It's asynchronous. All right, so you're seeing an example of what it might look like to deliver a standard lecture. But let's look at some of the other possibilities. So I'm just going to give you a pan shot of my apartment. You can tell it's a real kind of guy's place, right? Power tools in the living room. And in here is my video setup for recording lectures. Actually, just a tripod there with a GoPro mounted on top. And it's aimed at a whiteboard that I've got. Actually, I had this from a while ago. If you didn't want to or don't have access to a whiteboard, you could always have a bit of brown paper on the wall, or flip charts. You can even do this small scale, but I kind of like the idea of replicating what it looks like in a classroom for the most part. So you can see I've got the beginnings of my next lesson I'm running for my calculus class about trigonometric substitutions up there. So then next to the area where I'll be standing and filming, I've got a little table that I made some time ago that's up at a comfortable height for if you're standing. And there's a calculator and the textbook I'm using, markers and everything there, so it's all convenient. When you're actually using one of these GoPro cameras, it is controlled via an app on your cell phone. Well, it can be controlled from the camera itself, but it's sort of convenient to have it on your cell phone. In which case, I just leave my cell phone over in this area, and I can unobtrusively do things like zoom in, etc. Okay, so this is a workstation that I have set up in actually my my son's bedroom. So that's a little awkward, but he's not here during the day. And this is running Linux. So I'll show you here. I'd like to show you what we can do in terms of doing screen captured videos. Now I'll actually transition to the video itself in a second, but the idea here is basically that you can run various tools on your desktop. It's getting a little awkward, so I just put the camera onto a tripod. Let's see if I can put my foot back in here without knocking it over. Okay, good. So you're taking you should have a view of the screen of the PC I'm working at. This is actually a Linux workstation, the idea here basically is that you'll have a bunch of different apps you can display on your screen, and then you can capture the entire screen and switch between them with the usual Windows moves, right? So that, I mean Windows in the generic sense, not like in terms of the Microsoft's product. So a webcam together with a piece of viewing software is a good idea. You can use this in multiple ways. One is to show your own smiling face, but you can also set it up to be pointed at a sheet of paper, and you can be drawing or writing on that. Other apps, well, obviously web browsers, right? So you can have a web browser up. I was just playing around with an example here before, and so this is a problem for a calculus class, right? To find the area between x cubed and x squared in the region where x runs from 0 to 1, the so-called bounded region in the first quadrant, right? So, but that's just by way of nothing. This is an interesting phenomenon I didn't know you could do in Desmos before. It's to plot regions by specifying a range for the y-coordinate, and you can also, that's this other thing with the curly brace notation on the end is the usual way to specify the domain for a Desmos thing, but anyway, it's kind of cool that you can end up being able to show a region. The other thing I use a lot in my teaching, well, this is particularly because I'm doing a discrete math course this term, is CoCalc, which is a web-based, cloud-based actually system for letting people share and collaborate with Sage worksheets. So I've got do I have any files in this new project? I think I don't. So, this isn't a time to be demoing Sage, but the idea is there you could be looking at a computer algebra package, you can be looking at yourself talking, you can be looking at graphs, you can probably add to that list from your own imagination. One of the things I personally intend to do is display the slides that I would normally have for the course here on the screen. So we'd be switching back and forth mostly between the Sage worksheets and the slides. But again, that's personal choice, and it depends on the nature of the course. The big tools here are really things that you actually probably already have, a workstation that you're comfortable with. You are going to need to have software that does screen capturing. Now in Linux we have a couple of options for that. The one I'm using is called Kazam, and it allows you multiple choices here. You can go full screen. You can pick a particular window. I guess if this was a multi-screen machine, I could have all screens, but you see how that's grayed out. It's not available. You can specify a region. So, for instance, you might say that you might want to have some of your materials queued up on the side and use a region that doesn't include that. So you can go over off screen and double click and bring them into view. Personally, I'm just going to go with full screen most of the time, but being able to set a region is nice. And Kazam has this kind of nice feature, which I suspect many of them have, that you can you get sort of a countdown before you go. So we're about to be live. Okay, cool. Now we'll use our FM voice and try to be, appropriately professorial. Anyway, I'm going to transition now to showing you what video looks like from the perspective of a screen capture. Honestly, it won't be that much different from what you're seeing now, except that it won't be keystones because of the funny angle of the camera. So you're looking at a screen capture now. I should appear a little more straight. I thought it would be kind of a nice thing to show you this little device that actually came with my tripod. I'm sure you could pick one of these up somewhere, or even create something that does the same job for yourself. But a little spring clip thing that holds a cell phone and attaches to the tripod base. It's gonna come in handy. A lot of what we're after you can definitely do with a cell phone. There's no need to get a more expensive camera. Although, James, could you hand me your helmet for a second? Thank you, sir. My son is really into airsofting, so this is a helmet that he would wear, and the camera is rigged to go on top of it. So I'm basically borrowing the camera from him to do videos. No, that's a lie. We have two of them, so we're good. But yeah, these GoPro cameras are not that expensive. I think this one was about $300, and they're very high quality, and they'll take care of the focus automatically, all the standard things, and generally a lot higher resolution than the camera on your cell phone probably is. And like the camera, there's a mount that the GoPro can be attached to a tripod. I would definitely recommend, if you're going to be doing this stuff, getting yourself a tripod if you don't already have one. Okay, so I thought I would give a quick demo about how the screen captures presentations would really look. This is a Beamer presentation. Actually, it's full screen right now. One thing you're going to want to know how to go back and forth between minimized view and full screen. So there's usually a keyboard shortcut. It's different on different systems, but figure out what it is on yours and be able to do that. You're just going to tab, or in my case it's spacebar, through the slides, and the real content of these slides isn't so much the point. I was just wanted to give you an example of what it looks like. So for instance, at some point I'm going to be talking about the floor and ceiling functions in this slideshow. Let me show you that we can illustrate that kind of stuff in multiple ways. I mean, the familiar graphing calculators actually have, you can see I was checking it out before I did the math mode, and then under the second thing, num, there's something called int number 5 in that menu, and int of pi, well, pi being 3.14, hey, again, it's Pi Day, we should get 3 out of this. So there's a question about how that function actually works. You can see the line I did just above it, where the int of negative pi comes out -4. So indeed, this int function that's on the calculator behaves the way the floor function is done. So that's one way to use the webcam to display something like a graphing calculator. Of course, the other thing is to just write on it. I'd like to show them the notation. So if you say y is equal to the floor of x, show them those funny brackets. You gotta watch out for the way the autofocus works when you're on this kind of thing. So generally write and then get your hands out of the way so that the focus returns to the page. Y is equal to floor of x if and only if. What is that definition? Well, you need x to lie in between y and y plus 1, with an actual equality on one end and a strict inequality on the other. A less than or equal at the low end and a less than at the high end. So if you meet this condition, then y will be, in fact, the integer, the one lower than x, unless x happens to be an integer itself, which the drill on this, so I don't need it. But the point is that we can write our mathematics in a way that's reasonably attractive and display that for the kids while we're talking to them. We can return to full screen and continue with looking at the slides. need to not be in continuous mode while I'm displaying that. Otherwise, did you see that there was a, well, this goes to the way this Beamer actually works. What it does is creates a PDF file, and as you're revealing stuff, that what's actually happening is the next page of the PDF is being displayed. So if you're using PowerPoint or something that's really intended to be successive display of slides, you wouldn't have the issue that I was just having. Anyway, I think that's sufficient to get the idea across. So I'm gonna, oh, well, I was gonna mention some of the other things you can do, of course, is just display static stuff on the screen. I have this handout for the kids. It's in my, currently it's in my Google Drive, but it's also on our learning management system, so they can get to that. And this is a handout that they will get to use on our first quiz. I have this nefarious deal where I let them use it on a quiz, and then the next time around they're not allowed to use it, so it gives them a while to acclimatize themselves and a chance to learn the definitions eventually. Okay, so that's the end of this session. So we're back in my home studio. That is, we're being filmed on the GoPro now. It'd be interesting to see if when this video is all processed, if you can distinguish the difference in quality there. So to review, what I basically have been covering is how to capture your lectures. As I said, right now we're on the GoPro, but there are other options. You could use a cell phone. If you have a regular movie camera, a home movie camera, you can use that. An ordinary digital camera, often they will take movies. I used to have a nice SLR that did a great job with movies. And the last resort, if you have a laptop or a webcam on another computer, you could just aim that at yourself while you're writing things and record the output from that webcam stream. In my notes here, I've got a thing that says lectures equal bloodletting. And that's a point that's been made to me a couple of times, that the research shows that lecturing is probably the worst way to teach, that we're doing the equivalent of bloodletting, and that it doesn't kill the patient and probably doesn't make them better either, but so it is kind of the modality we're going to be stuck with as we transition to strictly online. But we should definitely be thinking about ways to engage the students more thoroughly. Watching good videos, hopefully videos with physical demonstrations as well as just us writing on a board, that would be a good idea. But that's not enough. We need to make sure that the kids are going to be engaged actively in what they're doing. Active learning is proven to be a better form of teaching, so let's go for it. There's lots of things you can do in that regard. For instance, get groups of students together in Zoom meetings and you oversee them. Occasionally joining different groups works. So that's, well, I'm sure we'll all have ideas coming up in the next few weeks. There's another issue that we should discuss, which is editing. Personally, I like the KISS principle, keep it simple, silly. You really don't need a fancy editor. You just need to be able to put a few clips together and string them into an extended movie. So, usually what happens is you're lecturing along until you make a mistake, then you stop the recording, and now you need to cut off a little bit at the end of that one and merge it into the next clip that you produce. So that's very fundamental editing. It doesn't require a real powerful tool. I'm using iMovie on a Macintosh, but there's a program I use on the Linux called Cinelera that works well. There's another Linux tool that I'm now spacing on the name of, but you get the idea. Finally, posting. I'm going to put this video on YouTube just to reach a wide audience, but you're likely to have support at your home institution for this. Our school uses Blackboard as the learning management system, and as an add-on to that, they have Kaltura Media. So I've uploaded a couple of lectures already to Kaltura, and it works fairly smoothly. Um, a note about your personal internet connection is probably worth making. I have a very asymmetric connection. It's through cable TV, really. I don't use cable television, but I just have the network connection through that. Download speeds are amazing. You know, you can watch high definition video without a single glitch. But uploads are pitifully slow. I was measuring things last night, and it's in the range of 250 kilobytes per second. Not exciting. That means a typical full-length lecture, 50 minutes of video, is going to take a couple of hours to upload. So if you also have asymmetric internet, you're going to see the difference quite remarkably when you're trying to upload large files. So plan for that. You're going to need to allow more time. I hope this has been of some help in the age of coronavirus. COVID-19 is forcing us all to adopt to technologies that maybe we'd prefer not to. I frankly think teaching in a real classroom, where you can see and interact with your students is way better, but I hope this will help many of us to do what we can in this environment. Thanks for watching.